Every government on the planet told you the same thing. We built the most advanced radar systems in history. Your skies are protected. The threat can't get through. They were lying, not because the radar failed, because it was built with a flaw they knew about before the first system rolled off the production line. A flaw so fundamental that fixing it would require admitting that billions of dollars in air defense investment was built around the wrong assumption. So they didn't fix it. They kept selling it. And right now, that unfixed flaw is the most exploited vulnerability in modern warfare. Let's get into it. Radar works on a simple principle. You send out a pulse of electromagnetic energy. It travels through the air, hits an object, bounces back. You measure the time it takes to return, and you know exactly how far away the object is. Simple, elegant, the foundation of air defense for 80 years. The problem is the word bounces. When radar energy hits a surface, it doesn't just bounce straight back. It scatters in every direction, and how much comes back toward you depends entirely on the shape and material of what you're trying to detect. A conventional aircraft is a radar nightmare to hide. Flat metal surfaces, sharp angles at the wing roots, engine inlets that act like perfect reflectors, external missiles creating dozens of additional return points. When radar hits a conventional fighter jet, it gets a massive signal back. Engineers call this a high radar cross-section. That's what every radar system in existence was designed to detect. And that's exactly the assumption that broke everything. Here's where the design flaw becomes irreversible. Every radar system in the world is built around a filter. The system sends out a pulse, waits for a return, and then that return goes through a signal processor that separates real targets from background noise. Birds, weather, terrain clutter, electronic interference. The filter has a threshold. Returns above the threshold get flagged as targets. Returns below the threshold get thrown away as noise. That threshold was calibrated for one specific type of return: strong, clear, high radar cross-section, conventional metal aircraft. When stealth engineers in the 1970s started shaping aircraft to scatter radar energy sideways instead of back toward the receiver, angling surfaces, eliminating right angles, coating airframes with radar-absorbent materials, they didn't make aircraft invisible to radar. They made the return signal small enough to fall below the noise threshold. The radar detects something. The filter throws it away. You didn't build a radar that misses stealth. You built a radar that's specifically designed to discard exactly the signal stealth produces. This isn't theoretical. It's been proven in combat. In 1999, Serbian air defense forces used a Soviet-era radar system operating at low frequencies. Technology NATO analysts had dismissed as outdated junk, to detect and shoot down an F-117 Nighthawk, the most advanced stealth aircraft in the American inventory, brought down by a system the Pentagon had written off decades earlier. The pilot ejected safely. The aircraft did not survive. The Pentagon's response was to classify the incident and quietly retire the F-117 8 years later. What they did not do was fix the filtering architecture that failed to track the aircraft in the first place. Think about what that decision reveals. A Serbian air defense crew using equipment the West considered obsolete shot down the crown jewel of American stealth technology. The correct response would have been to fundamentally rethink how air defense radar filters its returns. Instead, the correct response was to make the evidence disappear and keep selling the same architecture to allies around the world. Today, dozens of countries operate Patriot systems. More operate Russian equivalents. All of them are running the same filtering logic. All of them were sold on intercept rates measured against the threats the systems were designed for. None of the sales brochures mention the F-117. Because here's the thing, low-frequency radar has always been better at detecting stealth. The physics are simple. At lower frequencies, the radar wavelength is comparable to the size of the aircraft, which creates a resonance effect that produces a much stronger return regardless of the surface geometry. The Soviets understood this during the Cold War and built their networks accordingly. Western engineers knew this too. They chose not to build that way. Stay with me because this is where the flaw becomes a trap that nobody can escape. Low-frequency radar can detect stealth, but it has terrible precision. It tells you something is out there. It cannot tell you exactly where it is with enough accuracy to guide a missile to a kill. So you need two systems: low frequency for detection, high frequency for targeting. The problem is that the high-frequency targeting radar, the one that actually guides the interceptor, is the exact system that stealth defeats. By the time your low-frequency radar tells you something is incoming, Your targeting radar is throwing away the return as noise. You know something is there. You just cannot shoot it. Engineers have a name for this: the detection to engagement gap. It sounds technical. The reality is brutal. Imagine a radar operator watching a screen. The low-frequency system is throwing up a warning. Something is out there, inbound, altitude uncertain. The operator switches to the targeting radar to get a precise lock. The targeting radar shows nothing. Clean sky. No target. The operator isn't making a mistake. Both systems are working exactly as designed. One system sees a threat it can't precisely locate. The other system sees clean sky because the threat looks like noise. The operator has seconds to decide whether to fire a $4 million interceptor at a coordinate that one system flagged and the other system says doesn't exist. That scenario plays out in air defense operations rooms right now, not in theory, in practice. Engineers have a name for this: the detection to engagement gap. You can see the threat. You cannot kill it. And in air defense, a threat you can see but not kill is functionally identical to a threat you cannot see at all. The gap doesn't exist because engineers were incompetent. It exists because every design choice is a trade-off, and the trade-off that built modern air defense left a hole that every stealth aircraft, every stealth-shaped cruise missile, and every stealth geometry drone flies straight through. And here is the number that makes this a catastrophic problem rather than a manageable one. A Patriot interceptor costs between $3 and $6 million per shot. A drone shaped with stealth geometry costs under $50,000 to produce. The radar network protecting the target was engineered to throw away the return signal that drone produces. You're running a spam filter calibrated in 1985 on a 2025 inbox. And here is why nothing gets fixed. The companies selling Patriot systems have decades-long contracts already signed. The generals who approved the procurement retired into consulting jobs at those same defense companies. The governments that bought the systems already committed the budgets publicly. Admitting the flaw means admitting the contracts were wrong. The money was misspent. The protection sold to the public was incomplete. Nobody in that chain will say that, so the official position stays the same. High intercept rates, proven technology, your skies are protected. Which is true. Against the threat the system was designed for. The threat it was never designed for flies straight through. Most are still buying more of the same systems with the same fundamental flaw. Because the procurement contracts were signed, the production lines are running, the defense budgets are committed. And admitting the architecture is broken means admitting that 4 decades of air defense investment contains a structural vulnerability that no upgrade cycle fixes. So instead, the official position is that modern air defense systems have high intercept rates against the threats they were designed for. Which is true. Against the threats they were designed for. The Patriot works, the S-400 works, the Aegis works. Against the conventional high radar cross-section threats these systems were built to intercept, they perform exactly as advertised. The design flaw isn't that the radar doesn't work. The design flaw is that the radar works perfectly for the wrong threat. And the cost of building billions of dollars worth of air defense systems optimized for the wrong threat isn't being paid by the engineers who designed them. It isn't being paid by the procurement officers who signed the contracts. It's being paid by the operators sitting in front of radar screens watching the systems do exactly what they were designed to do, and missing exactly what they were never designed to see: you. The person living in any city that has a Patriot battery on the outskirts. The person whose government spent billions on air defense and announced it as protection against modern threats. Your tax money paid for those systems. Your government told you they work, and technically, they do, against the threats they were built for. The threats those systems were never built for. The ones shaped to look like noise, the ones flying below the radar horizon, the ones that cost $50,000 to build and exploit a filtering threshold set 4 decades ago. Those threats don't need to defeat the radar. The radar defeats itself. Every time it filters a return it was designed to ignore, it's doing exactly what the engineers told it to do. That's what makes this a design flaw rather than a failure. A failure means something broke. A flaw means it worked exactly as intended, and the intention was wrong. What happens next depends on whether the militaries still buying these systems acknowledge the flaw before it gets demonstrated at scale. In a conflict where the cost isn't measured in procurement budgets. The engineers knew. The procurement officers knew. And right now, the same physics that brought down an F-117 in 1999 is being applied to weapons that cost a fraction of what stealth aircraft cost. Because stealth doesn't require an F-35. It requires a shape, a geometry, an angle. A $50,000 drone with the right geometry produces a radar return that every filtering system on Earth was specifically built to classify as noise and discard. Not because the radar is broken, because it's working exactly as designed. The question nobody in any defense ministry is answering publicly is this: how many of the systems currently protecting major population centers are running filtering architecture that was calibrated for threats that stopped being the primary danger 20 years ago? That answer exists. It just isn't on the briefing slides they show to the public. And the next time that gap gets demonstrated at scale, it won't be a single aircraft over Yugoslavia. It'll be a swarm. And the radar network will see it coming. It'll just throw the signal away.